We're now going to go over examples for the lesson on proportional and non-proportional relationships. Specifically, this video is going over the number patterns part of the lesson. Number 1 is a list of numbers, and we need to find the pattern and determine the following three numbers of the sequence. To start off with, we should take the differences of adjacent numbers. So here 9 minus 7 is 2, 4 minus 9 is 5, 6 minus 4 is 2, actually 4 minus 9 is negative 5, 1 minus 6 is negative 5, 3 minus 1 is 2, negative 2 minus 3 is negative 5, 0 minus negative 2 is 2, and we can see here that the pattern is that it goes from 2 to negative 5, 2, negative 5, 2, negative 5, 2. So to find the following three, we just apply the following things. So 0 minus 5 is going to be minus 5, so that's the next number. Then minus 5 plus 2 is minus 3. And then again we have a minus 5, so minus 3 plus the minus 5 is minus 8. And those are the following three numbers of the sequence and the pattern. For number 2, again, we have the same kind of problem. Let's start by taking the difference of adjacent numbers. Negative 3 minus negative 5 is a positive 2. 1 minus negative 3 is 4. 7 minus 1 is 6. 15 minus 7 is 8. 25 minus 15 is 10. 37 minus 25 is 12. And we can see the differences go 2, 4, 6, 8, 10, 12, which are the even numbers. We could even go a step further by writing out these numbers as follows. Now, if you recall from the lesson video, D2 can be expressed as D1 plus some number Q. And this Q would also apply further down the line. We can find Q here because we know that D1, which is 2, plus the number Q is going to be equal to 4. So we know that Q is 2. What that means is that the differences increment by 2 every time. So now that we have a good understanding of the pattern here, we can find the following three numbers by, let's start with writing the following three differences. So we have 2, 4, 6, 8, 10, 12, and there's going to be 14, 16, and 18. So 37 plus 14 is going to be our next number, and that's 51. 51 plus 16 is going to be our next number, and that's going to be 67. And 67 plus 18 will be our final number for this problem, which is 85. Problem 3 looks quite a bit more complicated. So let's just start by taking the differences and seeing what they are. Negative 5 minus the quantity 2a minus 10 is going to be equal to 5 minus 2a. So now that we've found that difference, let's find the following. We have minus 2a minus a negative 5, which is just 5 minus 2a. And now again, just to make sure, we take the next difference. We have minus 4a plus 5, and we have to subtract a negative 2a. This gives us, not surprisingly, 5 minus 2a. So this is in fact an arithmetic sequence with a common difference of 5 minus 2a. We can now find the following terms by just adding 5 minus 2a. So to start, we have negative 4a plus 5. We add another 5 and we subtract 2a. We're going to get negative 6a plus 10. And now from that, we add another 5 minus 2a, and we get negative 8a plus 15. And again, for negative 10a plus 20. For number 4, we have a table. These are for sides of a polygon, like triangle, quadrilateral, pentagon, and hexagon, and the sum of the interior angles. This, like the previous problems, wants us to find the pattern and the following three terms. So let's start for the pattern taking the difference of adjacent numbers. 360 minus 180 is 180. 540 minus 360 is 180. And 720 minus 540 is 180. So this is an arithmetic sequence. The arithmetic sequence has a common difference of 180 degrees. And the following sums for numbers 7, 8, and 9 can be done by just adding 180. So 720 plus 180 is 900. Then we get 1080 and 1260. If we chose to go so far, we can even write this as a function of the number of sides there are. Because we start here at 3, as a triangle is the smallest polygon, the way we write our function is going to look like 180 times the quantity n minus 2. And the reason we do this is because if we were to go back one more, we'd get 0 degrees when there are two sides. So we just shifted this n minus 2 to account for that, and that way we don't have to add any extra term.